keep your x-intercepts and your min-max as you draw them, and do the transformation using those, and then complete the full graph. What did we say the intervals were? So on my, 90? Yep, 90 is good. 180 also works. It really depends on what you're talking about, but in this case, we'll keep with 90, 180, 270, and 360. And we'll go -2 to the left. And I'm going to skip a bit, but if we go 8 squares out, 2, 4, 6, 8, what would be out here? 720, that's right. So I have 2 cycles there. And if I have room here, 2, 4, 6, 8, -720. Doesn't mean we have to populate the whole thing. For now, we'll keep with -360 to 360. So it's the sine function. What y value does it have for x is 0? So for 0 degrees. 0, yep. And then what happens at 90? Goes to 1, then returns to 0, then -1, and 0. Now again, I kind of already created my scale here, so 2 squares was representing 1, just by placing those points. But that's arbitrary, okay? So on a test, that will give you the grid paper, but it's up to you as long as you make the transformation fit as well. So now I'm doing this in keeping in mind that I want to stretch it vertically by 2. So if we're going with connecting, actually, let's not connect yet. Let's do the second function, the g of x. So does anything happen to the intercepts, the x-intercepts, under the transformation? No, 0 times 2 is still 0. So the g will keep with the same x-intercepts. But what happens to the max and min? They double, so 1 goes to 2, and 1 goes to -2. And now I can connect, but I'm only going to worry about the sign in dotted form, and I'll draw the other one in continuous. So one was g of x, the other one was f of x. I'll label the f of x on the other side where there's more room. So if I continue to the left, can you guys complete this by yourselves? What happens at -90 with f of x? Yep, -1, then 0. What happens at -270? Yeah, well, max, I'm doing the main function, parent, but yes, the transformed would be there. Okay, so this one in here is our f of x, and that was our g of x. And just as a little reminder at the nodes, we're just going to remind ourselves that this point here is because 0 times sine of -360 times 2 is 2 times 0, which is 0. So that's why the nodes don't move. You don't have to write it in, it's just a little reminder. Okay. And now we'll do a compression. So we'll add here an h of x. So h of x, let's say I want to half it. Where would I put that in compared to sine of x? Where would h of x go? What happens to the y values if I want to vertically compress them? 1/2, okay, so 1/2 right at the front. And we'll call this h of x. So I already have my points, my maxima and minima. Now they're going to go to 1/2. The intercepts, again, will stay as they are. So we go with a similar wave to the one before, just a little bit shorter. And what would we call this? Label is h of x. Okay, so if we remember our terminology from last class, what was important? The period was important, and the amplitude. You can just make a new one if you want. You don't have to keep them all in one. Okay, so some thoughts here. So under vertical stretch or compression, what happens to the period if you compare the parent function to the transform function? Does the period change at all? No. Period remains unchanged. What about the amplitude? Yep, the amplitude increases or decreases. So only for vertical stretches and compressions. Once we start combining all the transformations, it's a bit different, but just remember to link this back to periodic functions and that terminology. Okay, the horizontal stretches and compressions, we'll do them a bit differently. We'll leave this for cosine, so leave the bottom of the page and we'll just go with horizontal stretches and compressions. Leave one graph empty. So horizontal stretches and compressions. We'll leave that one for cosine, right? So everybody sees where this is going. We'll do the same thing, but for cosine in a bit. We'll discuss the stretches and compressions first. Okay, so I'm going to take a g of x again, and let's say sine of 2x. And I put that in brackets, although brackets aren't really necessary. Sometimes you could be thinking of this as sine of 2 times x, but it's not the course for this, so it's still best to have your brackets in place no matter what. So what to remember, for horizontal we're thinking a little bit differently, right? You're tempted to say here that it's a vertical, horizontal stretch, but it ain't, right?
Compression by half.
By a half, that's right. So you go horizontal compression by 1/2. And this is where we're going to make use of that 720. So start marking your 90s, 180s, 270, 360. You don't really need to name all the ones in between, but 720 just so you know where to stop, because you are using quite a bit of symmetry here.
Can we have that 720 mark on both sides?
Yeah, left and right. Otherwise the 720 gets lonely. Yeah, we're going to stretch it out both sides. Oh, this is a compression, but we'll do the stretch on the same graph. So. Okay, so just to make things more visible here, I'm actually going to set the vertical to up here, let's say 4 units, 1 and -1, just to see it a little better once we compress and stretch. And to show that it's arbitrary. You can do this however you want. So once again, my sine starts at 0, 0, has a maximum at 90, comes back, a minimum at -1, comes back, and it keeps going every 2 squares. These nodes would be nice if they were a bit more visible, but we can all see them, right? The 90, 270. Okay. And let's go to the left too, just so we don't have to do this twice. So yeah. Okay, so the sine, the original sine is done. And now I'm trying to compress by half, which means all x values would go to half their original, right? So just be careful here. You might be tempted once you move the first one to just move it by 90 degrees, but it's only this one that goes 1 to the left. The 180 now goes to where? 90. To 90, okay, so I have my new point over here. What about 270? Yep, I'm just going to count the squares here, but yes, a half, so that goes right here. And then you keep going. 360 goes now to 180. And the last one here will go to here. And we already have a full cycle, so we can just keep going with the pattern. Okay, so it's just a very sharp graph. Oh, I misplaced this one. Nope, that was white. So once you have one cycle, you should just be able to use the square count to go through the rest of the graph. She does not go to 720. That's a bit ridiculous.
Oh.
Sorry? Oh, did you? It's okay. And then fill in the left. Just like Picasso did it, right? Okay, so I'm still going to draw in the sign here, so we have the original one, just to get an idea, but in dotted, very fine dotted form. Just to kind of see the effect of the compression. It just keeps getting better and better, right? So this here is your f of x. The yellow is your g of x. Now on a test, I would ask you, for example, for drawing this for, let's say, 2 cycles or 3 cycles. That means you start at 0, and you go to the left depending on what you get on the grid. If you get a grid that's both negative and positive for the x, you just make sure that you spread out. If I say 4 cycles, you have 2 and 2. So as long as you number the cycles, you should be good. So this here is your g of x. And now we're going to create an h of x that's going to be a stretch horizontally. Okay, so again, I go within that bracket, and it would be half x, or x over 2. And this denotes my horizontal stretch by how much? By 2. Okay, so stretches are always greater than 1. So again, I'm going to take those nodes, and what happens this time if it's a stretch? What happens to the x-coordinates? They double. Okay, so my first point here, from 2 squares, it goes to 4 squares, or 180. The node will stay the same because 0 times 2. And then the next one, we have a 0, which goes out here. And then every 4, so even if you have half a cycle now, you notice that half of the period is full. So if you're using a quarter of the period, you can keep going. So you have a quarter, this goes to the bottom, and finally 720. So really, once you have your first point, you should just be able to use a square count to get the rest, right? Because this function is split up into just 4 quarters. Quarter distance to the min, quarter distance to the max, and the distance between the nodes. So on the other side, I'm going from negative 90. That point will push out to negative 180. So I already have one curve. And then everything else, I'm just going to count 4 squares to the left, to the next 0. Okay? So this would go up here. And almost done. So this is h of x. So I'll just note here, focus on, after you set this up, you're just using a square count for the rest. Right, you're repeating those quarters. Don't try to look for those nodes that might be hiding underneath. Okay, so we notice here we'll leave 1 for the cosine there. But what do we notice happens under horizontal stretches and compressions? Does the period remain the same? Okay, so under horizontal stretches and compressions, the period increases or decreases. What about the amplitude? Does that change? No, the amplitude remains unchanged. Jasper, do you have this in your notes? Okay, in scribble form. Now leave a graph once again for the cosine. We'll do one reflection and then the good old translations. We'll do those 2 and 1 because we can handle it, I think. So let's say reflections about the x-axis.
So when we go back,
Yeah, leave 1 for the cosine. So reflection about the x-axis, I'm actually going to start with the cosine for this one. So let's say I have an f of x as the parent function cos of x. And I want to reflect into the x-axis, so what do I need to make g of x? Cos of negative x or negative cos of x? So either this or this, which of the two? If I want to flip about the x-axis. About the x, so I have to rotate, all points have to go from top to bottom, and whatever's on the bottom goes to the top. What coordinate changes? The first one, right? Because the y changes, right? Okay, so yes, I know. So it's the y coordinate. If it helps, you can put brackets around this, so you know the old y, which is cos of x, now goes to a negative cos of x. Correct? I'm glad you approved, Nicola. Okay, so we'll go with our scale. I know this is tedious, but since we're only graphing 360 here, let's do 90 a bit wider. So 90, 180, 270, and 360. And negative on the other side. And again, I'm not worried about any sort of vertical transformation, shifts, nor stretches. So I can put my 1, my amplitude, pretty high up. Just increase the visibility. Yep. Question?
No.
Okay. Don't forget, people, we're talking about cosine. So where do I start? At the origin, what is the y value? 1. Okay, everybody did their homework. Then what happens after 1? Goes to 0, then -1, then to 1, and back to 1. And I will complete the symmetric side on the other. Isn't this paradoxical? Going positive to the right into the future is actually backwards on the unit circle. I find that fascinating. The circle going this way is positive sense, right? So we're going backwards on the unit circle, but we're going positive onto the x-axis. So positive is going backwards, because time goes forward. Never mind. Okay, you can think about it. I'm sure it'll come to you. Okay, so let's connect just in dotted form. And then we're going to reflect all of this. But once again, those nodes, the points on the x-axis, will anything happen to them? What does that mean? Well, the nodes go anywhere under the transformation. In other words, would an x equal to 0 or y equal to 0 go anywhere else? No, y equals to 0, no matter how you times it, in this case by -1, it still stays 0. So my nodes will stay put. So I have this one and that one. That's a good point. But what about the maxima and minima? What will happen here? Yep. Okay. So they flip. Max becomes min and min max it. In a way, yeah. You can move it back left and right and match it up. But the max does become the min, right? Are we talking philosophy here?
Is that okay?
Okay. So this here is our g of x. And, whoa, that's delayed. Okay. That was a little odd. Then we have a max, and it ends on a minimum here. Okay, so our g of x, a reflection into the x-axis. We are done with that. Now I also want to look at what would happen if I were to reflect about the y-axis. So y-axis over here. We have cos of -x. That's right. Okay, so in terms of effort, it doesn't take much, but I will still draw another line on top. So as Jasper noticed, the points stay identical, right? Because my node there is right on the y-axis, and then everything else left and right, if I take this point here and move it to from the right to the left and vice versa, you get the same any point. So if I take this one here, if I were to mirror it into the other side, it would end up here. So visually, it's the same graph, but it is switched. So I'm still going to draw it in. Yep, it's the same as the original cosine, but you still have to indicate that there is a transformation. It's not the same points, okay? It's almost like having twins or something. Identical twins. Okay, so I'm going to denote this one as h of x. I have transformed it, it's just not a visible process. But you guys will have some fun with the sine function doing the same thing, the two reflections, and you'll notice that something happens there. So they don't both respond the same way under the reflection. Okay, so leave some room here for one more function. This is where you'll do the sine function, performing the same operations, so sine of x. So you'll do that all by yourselves in just a bit. For now, let's just note that under any reflections about the x or the y-axis, reflections, the amplitude and the period, do they change? No, so remain unaffected. It's just a little note. It's not something that you have to spend too much thinking about. Those are good questions for the multiple choice, right? So under any reflections, the amplitude and the period remain unaffected. Okay, and lastly, translations. Oh, I'm missing one. Okay, so translations, I will do 2 in 1. So let's say we have f of x is, we've done a lot of signs, so we'll go with codes for this one. And my g of x is going to be cosine of x minus, what should we say?
3.
No, so we have something that we can draw. That's the x, so the easiest ones are going to be 45 to draw, right? And let's say plus 1. Okay. So I'm going to start with the first one. We're only going to draw, I guess, into 360. So this would be our 90, 180, 270, and 360. Yeah, well, and a bit past because of our shift. And 90, negative 180, negative 270, and 360, negative. Now, what does negative 45 stand for again? What direction are we moving in? Yep, to the right by 45 degrees. And the plus 1? Up by 1. So we have a horizontal and a vertical translation. Again, I'll start with the main points. So for cosine, let's say this is 1 and negative 1. So positive goes to 0, goes to negative 1, to 0, and back to 1. And same on the other side. Okay, so that's my little sign. I don't even have to draw it with translations. It gets a little bit messy. So I'm just going to leave the points in. And if they're not visible, I'll just do a little green, green, green. Okay, and now I'm going to move it to the right 45. So I'll take each point and mark it 1 square to the right. Okay, so we're keeping the same y line. I'm not going to contour it yet. And finally, let's go to orange and plus 1. So the y-coordinate, the yellow, I'm going to move it 1 up. So for each yellow point, I will go 1 up above the axis.
Shouldn't it be 2 square?
Should be what?
Shouldn't it be 2 square?
Oh, yeah, that's right. Thank you. For the scale, that's right. So that would be here. Is that what you're going to say, Matilda?
Also the yellow?
Yeah, 45. What about the yellow?
Oh.
Yeah, so the yellow is just going to the right, and then we're going up to merge. So this would be our final. So technically here we finish on the 405. This is negative 305 or 315. And just for fun, we can draw the other ones. On tests, sometimes I do ask for all the stages, but make sure the other ones are in dotted lines so it doesn't overpower too much. Okay. So this is the g of x. And my yellow one is just after performing the horizontal, so it's just cosine of x minus 45 degrees. And we'll do one that's just a lot of fun. It's not really any sort of real purpose. I mean, I think you'll enjoy it, but don't panic if the expression intimidates you at first. So let's say I have sine of, sorry? Yeah, you will have a new graph. I'm just going to give it to you for now, and then you can go back and, let's say I have x minus 1 over 7 times 180. Okay, so no vertical movement, just horizontal. And then you can go back and fill in the other graphs for the other function. If we did sine, you do the cosine, and vice versa. But for now, we can discuss this one briefly. It's just a little mind game.
Not the same as that minus 45.
Not quite. It might be similar in value, but no, I don't think so.
What-
The 1/7 is intentional. You can't really simplify it nicely. But we have grid paper.
Only 4?
You can't approximate it, but you can use your grid paper. Okay, you can talk to your partners. What's a creative way around that? Remember, we drew most of these intervals with 2 squares for 90, but that is not fixed.
Use 7 squares for each 90 degrees?
Not for 90, but for 180. Yep. Okay. So use 7 squares for 180, and then there you go. Puzzle solved.
So count 7 squares and then mark that as 180.
Good thinking, team. Okay, so 0. Okay, so this would be the 360. This would be the 180. Now the half point is a little awkward, but the grid paper is still helpful. So the original one, let's say that's my 1, and my -1 is 3 squares down. Okay, and now we said we're going to move 1 square to the left and right. So negative was what direction?
Right.
To the right. Oh, actually, let's make it plus because we already have a minus. So let's change it to plus to go to the left. So this would go here. This would go over here. Negative. And I'm not going to bother with the left side, just the right side. Okay, that's it. That's the lesson. So all I want you to do next is just go back to those graphs. So this was f of x, this was g of x. So back to the graphs and just fill in the ones that we didn't do. So if we did sine, we do the cosine with all the transformations for now. And then we'll talk about a few combined transformations for sine and cosine. Does everybody have colors? Would you like some color crayon? Like I said, the best unit yet.